Hello everybody and welcome to Ferrovia Railway Design Workflow presentation. Ferrovia is a CAD software design solution which enables users to create any heavy rail, light rail, metro or other rail connected projects. And in this workflow example we'll show you the basic steps and enable you to have a quick hands-on of the software and to start your first projects, so railway projects using Ferrovia. Ferrovia provides a number of tools. First, alignment, profile, cross-section designing tools, and utility, where 3D modeling tools are available. Also, Google Maps import data is here, where we start today's presentation, selecting an area, inserting elevation data, and import raster, so the imagery from Google Maps source. Not so accurate, but for this purpose, very useful and a quick process how to start with any project. Here we have the elevation data that have been important for the selected area. And within Ferrovia software, there's also, so in the layout model, there is a terrain modeling tool. So first we define a surface name. And here we define the input data, either points, blocks, polyline, 3D polyline, or other elements. We have only points here, drawn as triangles in this example as selected. So we have our model already available. In this example, based on the same input data, we'll also create a civil 3D surface, since we are working on civil 3D CAD platform. And Ferrovia works with both. You can use Ferrovia's surface in CAD platform as well, AutoCAD, plain AutoCAD, but also bricks platforms. So a very useful tool to work on other platforms out of Civil 3D. Okay, so our surface is ready. We go to our layout module. We switch to our imagery just to follow one existing rail track. And in order to start our designing of a rail track, we define the alignment, the name, the starting station. There's a predefined option that alignment will be draped to the selected surface. There's a spiral type we can define. The category, we select the design speed, which influences on minimum parameters for the curves, spiral lengths, applied count, and everything. Then we go to our tool for designing alignment. So we have different methods of how to design an alignment. And here, just quickly, we define a tangent polygon, switch OK, which we can, of course, edit to a great level of details. So every curve, we can move the PI for each curve. We can insert PIs. We can change the radiuses, the spiral lengths, everything according to our needs. Okay, so in this case, we will just decrease this radius, which was in the area where we added the PI. And in this example, we just show the true point definition of a radius. So basically, either we type in the radius, or we can graphically define where through which point in the drawing the radius should go. Okay, let's say that we are now pleased with our alignment. For calculation of cant, so when designing alignment with tangent polygon, this cant is already automatically calculated. We can recalculate it using any of our pre-selected parameters. We have then cant editor, where we check the applied cant values. We can change design speed for a particular area, in this case for the last curve, which has a small radius, and the change of the speed is also we can see it on our alignment. Then we define the sample lines, which can be defined here in an interval along the entire alignment, or as in this example, just in, let's say, the second half of the alignment. With this, we can continue to our profile, draw the profile view. So everything is already pre-selected here. We can change those parameters as needed. All the geometry is already inserted into the profile view. So rail track, the horizontal elements, so the geometry, the cant calculation values. We can change this profile view to our needs. Basically, we can remove the profile bands just simply by removing those from the list. And we can also save these profile bands as our future profile insertion table. And we can also change the naming of any band here that's available. We'll switch that one to geometry, which is seen in this example. Everything goes, Ferrovia uses lots of layers, so everything can be changed to users' needs. Okay, we have everything set. What we need here is to define or draw the profile itself. So the vertical alignment for our rail track. Okay, so we insert it basically just by entering the PVI location, but then we can, to a very high level of details, set all those parameters to be according to our needs, basically defining station height of that PVI, what the slope of the profile should be, and everything else, what we need to be really accurate in this part of our design. Okay, so when we are pleased, we click OK, and now we have actually everything we need to draw the cross-section views for the sample lines that we added. So we only have them in the second part of the alignment. So here we have different options how to draw the cross-section view tables. Okay, we will insert them into the drawing. We'll insert them into the drawing. Okay, so here's our rail track according to our alignment and profile geometry, and by using our macro, so that's automatic cross-section geometry definition, we automatically design our ballasted bed, our subgrade, our cut and fill areas. We assigned the material to it already. Okay, so, and then we can just toggle on off the display of those materials. We can now display the quantity takeoff. So first is the areas that each material represents in each cross-section view, but then we also have the summary of the quantities, which we can save to external files, but also draw into the drawing, have this table, which can also be selected and exported to a CSV file and imported, opened in Excel file. We can define these projection points. So actually these projection points, you will see, so we define the cut and fill area here, and we will represent now the cut and fill hatches in layout based on those projection points. So actually we just use refresh layout, use the 3D alignment and cut and fill lines option here, and software automatically hatches and colors the cut and fill area which was defined in cross section. Also here we can draw the 3D model. So based on the material definition in cross section views, we invoke the draw 3D model command. So all the data is read from our cross-section definition, and we have a 3D rail track model basically in a matter of seconds ready in our drawing with all beam, let's say, data assigned to each 3D solid which is created. Then with the property set filter, we can simply hide, let's say in this area, the cut area so that we display this 3D geometry of the rail track. Okay, so just by finishing of this short presentation, with Ferrovia we can, as fastly as we did this simple single rail track project, we can create more complex ones to a great level of detail. So in this track, we also modeled also the rails. We added the rail envelope. We created all the cut and fill areas as surfaces, so to be more accurate. And we also added in some other objects like this noise barrier, but also here in this part we added some wall just for the sake of presentation, and we can always check whether this one interferes with our 3D model or not. Okay, so this was just a brief introduction, and thank you for today. Goodbye.